Hi folks, this is Calc 2 Take Home 7. We're asked to prove that a series is conditionally convergent. So we have to remind ourselves, what's it mean to be conditionally convergent? To be conditionally convergent, we have to show that the series as given converges, but that the series obtained from its absolute values diverges. Okay, so let's prove that the series itself converges. So as we substitute in values for n, the negative 1 to the n is going to alternate between positive and negative 1. So this looks like a prime candidate for the alternating series test. So for the alternating series test, we look at the absolute value of the given terms. We call those things a sub n. So a sub n is going to be the absolute value, negative 1 to the n, natural log of n over n. Since my n is bigger than or equal to 2, the only thing that's going to be negative in this is that negative 1 to the n power. So this simplifies to natural log n over n. So what do we need to show about these ANs? We need to show that their limit is 0 and that they're decreasing. So let's check that the limit is 0. As n traipses off to infinity, the natural log of n over n. I can go ahead and replace the n with the x there and get a function of real variables. This is the prime candidate for Hopital's rule. That's indeterminate form infinity over infinity. So we'll hit it with Hopital's rule. The derivative of the numerator is 1 over x. Derivative of the denominator is 1. That's the limit as x goes to infinity of 1 over x, which is 0. So since this limit of a real function equals 0, I can conclude that the limit then of this sequence is 0, which satisfies part 1 of the alternating series test. The second part is we need to know that the a sub n are decreasing. So once again, I'm going to replace the n with the x and look at f of x equals natural log of x over x. I'm going to go ahead and take the derivative of that. There are really a couple different ways to do it. You can go ahead and use the quotient rule. That'll give you one denominator. So you take low d high. So I take the bottom times the derivative of the top. That's going to give me 1 minus high d low natural log x. Now let's go look at what values of x I care about here. If you look up at the top, the series starts at n equals 2. So I'm looking for values x bigger than or equal to 2. And we have a little bit of a snag here, because in order for the natural log to get bigger than 1, x has to be bigger than e. In other words, this function isn't decreasing until x is bigger than or equal to e. At that point, then it's decreasing. The derivative is negative. So we remember that we would say that for x bigger than or equal to 3, f prime of x is negative, which means that the ANs are decreasing, which would then imply, by the alternating series test, the sum n equals 3 to infinity of negative 1 to the n natural log n over n converges. But since a finite number of terms does not affect the convergence or divergence of the series, the original series starting at 2 converges also. Okay? Another way to say it is as long as these conditions are met at some point on. So for some point on, the sequence is decreasing. So in other words, as long as the tail of the sequence is decreasing, then you're fine. Okay? So that shows that the series as given is convergent. So let's look at the series obtained by taking the absolute values. We have to show that it diverges. And in fact, we know what the absolute values are. We had them for the alternating series test. It's natural log n over n. Now notice here the n is bigger than 2. Okay? Well, let's go back to our argument before. Let's look at the natural log of n. The natural log of n is going to be bigger than 1 when the n is bigger than 3. So if I look at the series n equals 3 to infinity of the natural log of n over n, then here's what I can say about that. I can say that the natural log of n is bigger than 1, which means the natural log of n over n is bigger than 1 over n. And so by the direct comparison test, as the series n equals 3 to infinity of 1 over n diverges, because it's a p-series, and p equals 1, which is less than or equal to 1, right? It's a harmonic series. So does the series we're given, the series n equal 3 to infinity, natural log n over n. But once again, a finite number of terms does not change convergence or divergence. So hence, the series n equals 2 to infinity of the natural log of n over n diverges. And so folks, that'll do it for Take Home 7.